This video will cover vertical dilations of functions. So we're going to just cover some terminology first. Dilation is the process of stretching or compressing the graph of a function horizontally or vertically. The scale factor is the value of k by which the graph of a function is dilated. So a dilation stretches or compresses a function, changing its size and shape. We will investigate the effect of changing the k value on the following functions on your screen. On your screen you can see the functions plotted, and as k increases there is a vertical dilation. As k decreases into the negatives there is a flip, a reflection onto the on the x-axis, and again a dilation occurs vertically. So again, notice that k stretches the graph up and down along the y-axis and changes its shape. This is known as a vertical dilation. So the value of the parameter k controls the amount of stretching or expanding, or shrinking, compressing. We call k the scale factor. So as k gets increasingly large, bigger than 1, the graph is stretched or expanded. If k is between 0 and 1, the graph is shrunk. The same operates in the negatives. As k gets increasingly negative, the graph is stretched. If k is between 0 and -1, the graph is shrinking. Remember, if there is a negative value, it's a reflection on the x-axis. On your screen, you can see an example of a parabola in red and some scale factors that have been applied to each one. As previously mentioned, a vertical dilation with a scale factor of -1 or a negative flips along the x-axis. Because we've made the scale factor -1, you can see that there is a reflection of x squared minus 2 on the x-axis. We will now answer some questions. So the first one is to describe how the constant affects each transformed graph given the parent function and state the scale factor. So for the first one, y equals 6x, we know it has a scale factor of 6, and we know that the graph, the original function, is stretched as the scale factor is greater than 1. As for the second one, y equals -x, we know that the scale factor is -1, and because it is -1, there is a reflection on the x-axis. Before we move on, I'll show you a graph of this. On your screen, you can see the original function. When there's a scale factor of 6, it is stretched on the vertically upwards. And if we have a scale factor of -1, there's a reflection on the x-axis. We'll now look at the function y equals the absolute value of x. For this function, our scale factor is 5. The original function is stretched. If we look at the next one, it might be easier to find the scale factor if we show it as this. So the scale factor is 1/8. And the original function is compressed. On your screen you can see the original function, And there it is with a scale factor of 5. You can see there is a vertical dilation being stretching it upwards. And then here we have a compression towards the x-axis. Find the equation of each transformed function after the vertical dilation. So we have the original function here. Remember, when you're adding a vertical dilation, it is a k factor. And if we know our scale factor is 1/3, we simply add 1/3 there. Another way you could represent this is y equals x squared over 3. Point M36 lies on the graph of y equals fx. Find the coordinates of the image of M when fx is dilated vertically with a factor of 12. Dilations only affect the y value. So if we had 3, 6 in the original, our transformed function will be 6 times the scale factor. So the new coordinate is 372. To end the video, we'll do a quick recap. So remember, k controls the amount of stretching or shrinking that occurs, and we call that the scale factor. If k is greater than 1, the graph is stretched, it's narrowed towards the y-axis. If k is between 0 and 1, the graph is shrunk or compressed. Alright, the same occurs in the negatives. If k is greater than -1, the graph is stretched. If k is between 0 and -1, the graph is shrunk. On your screen you can see an example of the changing k factor for a function x squared. Remember also that there are reflections in the x-axis, and if the scale factor is a negative, -1, this creates that reflection along the x-axis, and you can see the reflection of x squared minus 2 there when we make the scale factor -1.